Alright, so to understand exactly what each factor and therefore each root tell us about a particular polynomial, we're going to look at two examples, sketch the graphs, and see what we can learn from both examples. So the first one we have here is f of x, and what I would like you to do right now is just pause the video, write down what you know about the function f of x, and go ahead and try sketching a graph yourself, and then come back and we'll take a look. So hopefully that went well. First thing that I note about this function is that it's going to be a third degree polynomial, and the leading coefficient is going to be positive. So it's going to have the same shape as x cubed. And then I note that since it's a cubic function, obviously, and there are three factors, that is going to give me three roots. And so my roots are going to be x equals positive 1, x equals, x equals negative 2, and x equals positive 4. If any of that is confusing, pause the video and try plugging in each x value into the function. So for example, try plugging in positive 1 into the function and see what happens, and then do that for the other two. So knowing these roots, I'll go ahead and mark them down. Negative 2, positive 1, and positive 4. 2, 3, there we go. Now I can start to think about, okay, what will this function look like? So if you haven't already, go ahead and graph the function, taking into account the overall shape and of course the roots, and then come back and we'll take a look. So you may or may not have realized in graphing the function that there might be a couple of ways you can graph it. So let's just take a look at one possibility. So I know I'm going to come up from the bottom, from the negative side, and let's say I cross through the x-axis here, come back down here, and I go up that way. And that works, that's just fine. But perhaps you also notice that, hey, like, instead of going positive here, what if I came up, I hit at negative 2, and I bounce back down, I hit at negative 1, I came up, hit back down at 4, and then went upwards to continue on. And for a second, just stop and think, does that satisfy the conditions that I laid out at the beginning? Well, yeah, it does. Both functions have roots at negative 2, positive 1, and positive 4. And they both have the basic shape of a cubic polynomial with a positive leading coefficient. So what we want to try and figure out is, okay, what's right and what's wrong, right? We can't have two functions, or two graphs representing the same function that are different. So at this moment, I want you to pause the video and I want you to take a look at both graphs and figure out where are they different. Alright, so the first you should have noticed that they are different. I'll use a different color here. They are different in between the roots, right? The end behavior is the same, but in between each of the roots, they are different. So let's just talk about the first place where they're different, which is in between when x is negative 2 and x is positive 1. How are they different? Well, the white function is positive for all those values, and the blue function is negative for all those values. That's the only way it can be, right? Think about it this way. There's no way that the blue function could come back down, be negative, and then somehow go positive before hitting the next root. Why is that? Pause the video and think to yourself, why can't it be going negative and then go positive before hitting the next root? Hopefully you realized, hey, it only has roots at negative 2, positive 1, and positive 4, right? It's cubic, it has 3 roots, and that's the only way it can be. So it must stay either completely negative or stay completely positive in between those two roots, and we want to figure out which one. So what can we do? What could we use to test whether it's going to be positive or negative? Take a second, stop, see if you can come up with a test it yourself, and then press play. So in thinking about how we can test, remember that it has to stay, so if it's going to be positive, it has to stay positive until it hits the next root. And if it's going to be negative, it has to stay negative until it hits the next root. And that has to be the case. It can't change sign. So at any point in between -2 and +1, it's either going to be positive or it's going to be negative, and that's the way it's got to be for all x values in between -2 and +1. So why not just try one? Let's try some value in between -2 and +1 and see whether it's going to be negative or positive. Negative or positive. Well, let's pick one. What's the easiest value that you might want to be able to plug in that's between -2 and 1? Most people are going to choose 0. However, it works for any. So if you have your doubts, maybe choose a different value and we can compare. So let's go ahead and test. If I plug in 0, if I plug in 0 for x, f of 0 is going to be -1 times +2 times -4, which is going to give me a positive 8. Right? Negative times a negative will be a positive 8. And so I can see at x equals 0, I must be positive. In fact, I know it's going to be exactly positive 8. And so the blue function can't be correct, at least in between those two places. All right. So we've got that one squared away. Well, now let's think about the other place where there's a differentiation. So there's a difference between the next two roots. Now imagine, we know already that it's going to go up through -2, it's going to come back down, and it's going to hit at +1. But we still could go bouncing back up, hit at 4, and then go upwards. Or we could pass through, be negative between 1 and 4, and then pass through at 4, going upwards. So we still have to decide positive or negative here. I want you to pause. I want you to do a test on your own, and then come back and we'll check. So hopefully you were able to come to a concise decision. What we want to do is test some value in between 1 and 4, because it's either going to be positive all the way between 1 and 4 or negative all the way between 1 and 4. And if we go ahead and choose +2 here, and let's test that out, if I plug in 2, f of 2 is going to give me a +1 times a +4 times a -2, which is going to be -8. -8. And so my only option is for when I'm between 1 and 4 for my function to be negative. So what I want you to do now is go ahead and verify the graph that will fit this function, sketch it again, and we'll take a look. So the function's got to start negative, it's going to pass through -2, it's going to be positive all the way until it hits 1, then it's going to be negative all the way until it hits at 4, intersects the x-axis, and then it will continue going positive as it is a cubic function. And so that is how my function must look. Okay. So now we're going to look at one more example, and hopefully this will clear up for us kind of how we can learn exactly what's happening at each root and kind of come to a decision on how we should treat different roots. So let's look at g of x, which is x plus 2 quantity squared times x minus 1 times x minus 2. So once again, I want you to pause, I want you to decide what you know about this function, graph it, and we'll come take a look at what the correct graph should be. Alright, so hopefully you realize this is going to be a quartic function, degree 4. Reason being is that x plus 2 squared means you have x plus 2, and you're multiplying by itself, so you have another x plus 2, and then you're multiplying by x minus 1 and x minus 2. Alright, so go ahead and create our graph here. We know, of course, that a quartic function and this is going to have a leading coefficient that is positive, so it's going to be x to the fourth is going to look like. It's going to have a basic shape like that, right? The end behavior is going to be going positively in each direction. And we know the roots, right? We know that the roots are at -2, +1, and another one at +2. So I have -1, 2, +1, +2, and I'll just go ahead and mark those down. And you may be thinking to yourself right now, well, I have 2 roots at +2 because I have 2 factors here. And you'd be right, because remember we talked about the number of factors tells you the number of roots, and a 4th degree polynomial has got to have 4 roots. And so you're correct in saying that each of these roots gives you, each of these factors gives you a root, but that root happens to be the same one, -2, and so we can only hit that point once. So in our graph, it's going to look sort of similar, but we're going to notice that there is a little bit of a difference. So in graphing it, we will of course start positively. It's going to, select the pen there, it's going to drop down, it's going to hit the x-axis at -2, and let's think about it, okay, so let's just say it goes through the x-axis there, it hits the x-axis at -1, at +1, it comes up, hits again at +2, and then continues its way upwards. Let's just say that that's what it looks like. Do we know for sure? Is there another way that we could graph it? And certainly you'll realize, yes, there is. I could, again, starting with the same end behavior, hitting at -2, but instead coming off the x-axis, coming down, crossing through at +1, and then reverting back upwards at +4. And we see that this graph will differ in 2 ways, and we need to figure out which way is correct. So what I want you to do is pause the video right now, try and figure out which one is correct, come back and we'll talk about it. So the 2 differences occur in between the roots again. Do we stay positive this whole time in between -2 and +1, or should it revert down and go negative? What will be the correct decision between those 2 roots? And if I plug in a value in between there, say 0, let's plug in 0, and what are we going to get? Well, we're going to get 2 times -1, which is going to be negative, times -2, which is going to be positive. So we can see that the correct decision is going to be to stay in the positive direction and bounce back up off the x-axis. Alright, what about at +1? Well, if I plug in a value in between +1 and +2, what will happen? Will it be positive or will it be negative? What's the value between +2? Let's try 1.5. So if I plug in 1.5, this will be positive, this will be positive, this too will be positive, but 1.5 minus 2 is going to be negative. So the value I'm going to get is going to be negative. So the correct graph is going to look just like that function I drew first. And it's going to go straight up. It's going to bounce off, come through, and then head back up. Okay? And that's the only way it can be. So what do you notice? How does the function, the sketch of the graph, how does it react at the roots? Go back to our first example. Notice what happens at each root. At this root, everything was negative until it hit the root, and then it became positive. It passed through the x-axis. Then at 1, once again it was positive. When it hit 1, it became negative, passed through the x-axis again. Here, again, it passes through the x-axis, went from negative to positive. Did that happen with every root in our second example? You'll notice that it doesn't at this root at -2. Well, what is the difference between the roots that pass through and the roots that bounce off? Hopefully you notice that this root is repeated. It has 2 factors that give that root. And so why